Sorry.
It's all right.
Okay, so let me start again. Okay, so welcome everyone. Okay, so today we're going to have two sessions. First is with Mr. Daniel Yap, and then we will continue with Dr. Lee and Sang. So before I start, let me introduce to all of you about our speaker today. Mr. Daniel Yap received his Bachelor Engineering in Electrical and Electronic Engineering from University of Technology Malaysia in 2002 and completed his MBA from University of South Australia in August 2007. He joined Agilent Technologies in 2005 as a material engineer and since then has held a variety of engineering roles, technical marketing, product support, and business development in the areas of microcomponents and network analysis. In April 2016, he has been appointed as Asia Pacific Education and Research Business Development Manager, which focuses on collaborations with universities, researchers, and professors on new research discovery and supporting their high-impact research work. This also includes exploring new teaching solutions in engineering studies. By now, he has more than 100 universities and research institute engagements. Daniel has also been appointed as University Industry Advisor Panel for University of Malaysia Perlis and Curtin University Malaysia and Board of Study for Technical University Malaysia Malacca Technology Program in 5G. In his spare time, he enjoys mountain biking, cycling through the various orchids and hills in Penang Islands. So without further ado, please welcome Mr. Daniel Yap.
Thank you for the nice introduction, Dr. Saidatu. So good morning, everyone, and good evening and good afternoon, wherever you are today. So I'm going to share my screen right now. Let me know if you can see it. Yep,
Okay. Yeah, it's good.
All right, it's good. Okay. Okay, put into full mode. So if you have any questions, please feel free to ask in the chat box. I'll answer one by one on it. So first of all, Keysight technology we are at the heart of digital revolution. In fact, maybe some of you do not know who is Keysight. This is actually a new name, but it's not a new company. We have started as HP, Hewlett Packard, and then after that we changed the name to become Agilent Technologies. And over the last 5 years, again we changed name again, become Keysight Technologies. So Keysight, new name, but not a new company. So why are we at the heart of digital revolution? If you look into this slide here, Keysight is actually a center. We like to position ourselves as a technology enabler in wireless, automotive, aerospace and defense, IoT, networking, and cloud. So in fact, today, a lot of these smart technologies that connects to the world, Keysight is also part of it. So we are playing a very vital role in accelerating the innovations and also to connect and secure the world. So here is some of the brief facts about Keysight. We are the market leader, more than 80 years of expertise. And then we have more than 1,700 US and foreign patents issued and pending. 29 of the top tech companies uses Keysight. In fact, most of your gadgets today or electronic gadgets, we are definitely there playing a role. Our company revenue in a year is about 4.2 billion. And in fact, Keysight is also the leader in 5G and technology enabler. We have released more than 12 market-ready 5G new radio solutions. And to continue from that, Keysight has also started our 6G research engagement activities with several strategic sites around the world. And finally, 78 of the global 100 companies are Keysight customers. At glance, this is the picture. The gentleman on the right-hand side is our president and CEO. raw narcissus. Our headquarters is located in California, Santa Rosa. And we have customer location more than 100 cities or 100 countries. In fact, manufacturing and R&D location spread across several regions, US, Europe, Asia, Pacific. And the biggest site, we call it campus or Keysight, is actually located in Malaysia. That's where I am based at Penang. So you can see we are the #1 in wireless communications. A lot of these chip makers, telco operators, and NEMs are actually working closely with Keysight in releasing the first 5G solutions in their home country. Okay, next is Keysight and research. Part of my role here is actually to work with universities and research institutes. We actually look into a lot of meaningful collaborations, things that how we can actually have a mutual benefits and supports. Of course, as for Keysight, we also look into a lot of talent hiring. That is the reason why Keysight are working closely with universities, educators to help in the talent development. Now, I want to show you some of the very recent kind of like collaboration we had. For example, we do have a big collaboration with MIT on the quantum computing lab. So we have a lab set up there. We also are working on a 6G research with University of Oulu. So this is not something new. It has been a traditional go-to university since many years ago from 5G. Okay, and then next is we also have a battery test solution together with National Vehicle Testing Center in China. And of course, as all of you know, China is one of the biggest driver in electric vehicles. Next is we also have a lab, some sort of measurement technology lab set up in Singapore University of Technology and Design, where this lab actually has a lot of breakthrough. One of the breakthrough was actually in Bluetooth security concern. They call it the breakthrough. So this actually, that I'm wearing a Bluetooth headset right now. There are actually security concerns where you might experience some drops, or what happened during the drops. Maybe attackers might be taking advantage on this data. Next, we also have a research collaboration with NTU, Nanyang Technological University, in the development of IC for hybrid vehicle to everything communication testbed. On the talent development, we do have a collaboration with Center of Technical Excellence, Malaysia. This is related to IoT program. Other kind of research area are like 5G massive MIMO, test and measurement methodology, photonics IC research with China as well. And one of the very cutting edge, I would say diagnostic area will be the portable brain scanner research, such as we work with EM Vision. In fact, EM Vision is actually a spin-off from the University of Queensland. All right, so this is overall on the collaboration we have with universities around the world. Now, of course, my title here, I put it Opportunities for Malaysia Education Institution. Now, this is not limited to Malaysia. After I understand from Sadatu that we have participants from other countries. Now, it can be very applicable in your home country as well, where you are currently located. So the topic is related to remote learning, okay? So I'm taking one example from here. This is a very recent Malaysia plan, long-term plan for the next 5 years. In fact, the government actually identified 2 key areas to boost the national development. Under the topic of Chapter 10 is about developing future talent. You can see that realigning the labor market for inclusive and sustainable growth, developing for future-ready talent. The second one will be Chapter 11. It's about advancing in digital economy, mainstreaming digitalization, inclusive development, accelerating R&D for commercialization and innovation, and of course, capitalizing on advanced technology potential. So this is something that close for most of us in Malaysia, but it's also very applicable throughout the whole world today. If you need more information, there's actually a link here, or you can do a search and look for RMK 12 Malaysia plan. Now, how to relate? What I was saying earlier on actually relates to this actually. I use the word Malaysia, but this is not only Malaysia, but can be any other countries too. These are the top use cases in digital ecosystem. If you look on the left side on this text, 5G is actually an technology enabler in many areas. If you look down here, it's just listed down 13 of them: oil and gas, smart factories, agriculture, airport support, energy preservation, e-government, all these. These are all the very relevant use cases. And in most of these cases, you will see that challenges, constraint in every single area. Okay. Here is another graph on another representative of use cases. Okay. So to talk about challenges, digital transformation, 5 of the success factors, can be more, but here are the 5. Other than infrastructure, other than like things like spectrum availability, networks, innovation system, business climate, talent is one of the major concerns. Why? First of all, technical skill talent are needed in every single use case. You need to have data scientists, you need to have a software engineer, you need to have app developers, you need to have someone who is good in cyber and network security, and you also need someone in a wireless comm and connectivity engineers. Also, of course, hardware, embedded firmware engineers, front end and back end developers. In fact, to talk about US itself, this is actually a survey, research survey, a survey done by Boston Consulting Group. It stated that even US have the top best world-class university in the world. Their education system is not producing enough technical talents specifically about digital transformation. Now, you can imagine if you are running a big multinational company or running a firm and enterprise, in order to capture into this fast-paced digital economy, you too need to hire talents. You need to perhaps send your engineers, send your team members for training too. So in the short term, in the immediate and the medium term, this type of skilled workers are very much lacking. What is also interesting here is, according to the Chronicle of Higher Education, this is another survey, a survey being conducted about 855 senior administrators and faculty members from the education institutions. More than 90% respondents actually agree that they need to understand more about technology than before the pandemic. In fact, it was actually interesting how actually we were talking earlier on that even my daughter today, she is actually forced into online learning. As a parent, I'm also forced to learn what is available in Google Classroom. Now, to talk about that, in education, in our education institution, as an educator, you too need to know what is actually available, what can help you to increase your workflow more efficient and effectively. So I think 90%, more than 90% agree in this. And my message here is Keysight is at the front end. We are here ready to assist you to look into ways how we can support your education needs. So having said that, again, relate to the hybrid learning. Many of us actually also agree the hybrid learning is a way forward moving on, even after the COVID situation settled down. But again, we know that there's still many uncertainties. The effectiveness of the vaccine are still not 100%. There's also discussion to talk about. You need to have booster shot and so on. So hybrid learning is an option that we see a lot of countries today are putting into some sort like must to have kind of criteria in every learning. And that actually, in fact, if you are teaching engineering program, especially in RF or communications, that students need to use lab as a part of learning, it is a challenge. It is a challenge. In fact, we have been looking this even before the COVID situation. Keysight actually tried to assist university to upgrade and advance their learning environment. So we see that this is an opportunity and Keysight has actually developed this ahead. So I just want to briefly talk about what are the key components to make a remote learning or hybrid learning successful in your university or in your program or in your course. First, we do have this kind of like PathWave Remote Access Lab software. It is a software, 100% software based that is supported in your LMS, and most of the universities in the world are using LMS today. So this plugin, we call it the LTI. It is actually incorporated to allow universities to conduct remote learning, grading, quiz, and also, most importantly, to continue the remote learning according to industry needs. Second will be I would say the lab manager software. Is actually a centralized lab configuration asset management. What is really interesting is, you can imagine, if you are teaching in the lab, you and your lab managers, you have maybe about 50 benches or 100 benches or even like 30 benches. With this software, everything is connected, everything is integrated. Educators like you can deploy your assignments, you can deploy the lab works simultaneously, all go at once. You can even record, monitor, you can, I would say, do firmware updates, reset the stat of the instrument, all together at once. Looking from the industry side, hey, this is very similar to how our engineers are working today. During this lockdown, most of our engineers are working from home. Of course, there are some other colleagues, staff are working in the site to make sure the operation is running. But engineers, they are actually accessing their instrument to check the performance, the yield, everything remotely. So this is exactly how we are doing the same thing as well. And finally, Keysight, we do have a switching system. We call it a DAQ, data acquisition system, or some of you might say it's a multiplexer and so on. So with this system, it allows you to connect your DAT, device under test, material under test, system under test, remotely. It gives you a lot of flexibility. For lab manager, for educators, this is very helpful that you only need to do this once. After that, the student will access it. They can change the switch on and off, set the setting, set the power, set the frequency range, set the bandwidth, try to look what is a 3 dB cutoff, what's the Q factor, everything remotely. It's exactly how we are working from R&D center from the industry. Now, to show you that this is already being implemented by some of the universities, I like to quote several universities. Perhaps here, if you see the first one is Youngstown State University. This is ranked about more than 600 in the world for year 2022. So Youngstown University actually has a very interesting situation. First of all, educators, they actually looking into modernize their teaching lab. So the current solution they have, they do have remote access, but it's very lack on engineering curriculum integration. Now, everybody can do online learning, remote access, but to do a very engineering focus, not many tools can do that. Okay. So what happened is, actually Keysight, we jump in, we have supported the university. We help them to set up a remote lab that not only cater for now, but also for future. So this is actually a very good kind of collaboration we work with. We actually assisted, and with this success, it actually turned out it attracts more students and more enrollment. Now, some of the universities that we know, example, maybe a private sectors, maybe even public universities, student enrollment actually affects the university revenue a lot, right? So if you do not have enough students to enroll in that program, it affects the university revenue. So we are actually helping the university to sustain, in fact, not only sustain, to generate additional revenue in this area, but again, also to deliver a new learning experience to any students located anywhere. So at the end of the day, it is actually very interesting to see that how Youngstown State University, because of this success, they actually able to work together with other universities who are in need for support to deliver engineering learning. So they work with University of Michigan, Spelman College, Morehouse College in Georgia. So with one setup, Youngstown State University able to expand their relationship, collaboration with other engineering institutions. Next, this is a case study with University of Houston, ranked 601 to 800 in the world. Now, what is really interesting here is, I like his comment on here by Dr. Len Trombetta, who is the, I would say he's the Dean, the Department of Academics, Head of Academics. He said, the professors are real, but they are not in the room to give pointers. The device under test is real, but it's just an image on the screen for students. And many schools, because of cost, availability, and other factors, the remote test equipment is real, but the industry doesn't use it. What does it mean? It means, yes, you can set up a lot of things, but think again, hey, this is not the industries are looking at. Sometimes, you can go to simple setup, but I think we have a responsibility here for the students too, and the industry. We are also looking at, hey, if I want to hire a student or fresh graduates, we are actually looking into many areas. Are you ready to work? Because supposedly we are always being, even Keysight itself, we are always being told, say, hey, my students are industry ready, hire them, they are good. But sometimes when it comes to real expectation, there is still some sort of lacking. I would say it's not perfect, which actually a lot of improvement can be done. So what did Dr. Len Trombetta said is, so they actually approached with Keysight. So we actually assist and set up benchtop, but in terms of measurement, it's fantastic. If you need this case study, you can go to our website and download. Otherwise, stay on till the end, because Dr. Lee will show how does a real industry measurement being done, exactly that in a lot of companies as well. Another university called Chapman University. What is really interesting here is, like most universities around the world too, a lot of them they do not have enough knowledge. Just like, the earliest survey by Chronicles or Higher, that survey say that a lot of educators today, they need more knowledge, they need to understand more what is available and how to do it. So Keysight actually, we jump in here and assist Chapman universities to set up electrical engineering programs. And also not only that, but work with them together, making sure that it ties to the requirement, to the professional bodies, to industries, and that program is industry relevant. So on the impression side, it is very interesting to see that we actually enable the university not only one lab, but expand for future multi-lab setup. So today, most of you here are RF background. With this setup, perhaps same thing, one software, you can manage the electronic lab, photonics lab, embedded lab, IC lab, and so on. So many engineering labs you can get it connected. That will actually, maybe if you are a dean or a department head or a university executive, you will see that this is an opportunity to do cost saving, to increase efficiency, to deploy student enrollment effectively. I would say that if you have an LMS system, take advantage of the LMS system like Canvas, Blackboard, and Moodle, because it's a single sign-on, very secure. Nobody can enter that, access that lab without through the single sign-on on the LMS. You can track the students' learning. You can track who accessed it. Everything can be tracked and complete everything remotely. Now, the final one will be University of California, Santa Barbara. This is actually published as well in general for public reading. So one thing that is interesting is not only a normal basic laboratory can be done, even a photonic lab setup can be set up as well for remote learning. So the professor actually commented that our solution is an integral to launch of the inaugural quarter of undergraduate photonics laboratory. So it actually provides a seamless bridge to actual hands-on laboratory for the students. Okay, so we are very proud on this success, because this is actually proven to be a moving forward technology. We are very happy that, because also we know that when we hire the students from this lab, from this university, they are already being exposed on such modern learning. Well, you can say this can be part of I'll say IoT. You can mention that this is part of Industry 4.0, because again, your training kit, your data, your measurement can be anything, can be a device, and you are drawing measurement, drawing data, analyzing the signal, and so on. Okay, I think this is my last slide. If you have any questions, please feel free to put out in the chat. I will maybe go through this and answer at the end. I'll stop here. Dr. Lee, Saidato, can I pass this back to you?
Yes, thank you, Mr. Daniel. So we can proceed with Dr. Lee and Seng on demonstrations for the lab. But before that, let me introduce Dr. Lee and Seng first. Okay. If you guys have any questions, as for now, perhaps you just can write down your question at the chat area, and don't forget to fill out the attendance form. Okay, so we will provide the e-certificate as well. Okay, so let me introduce a bit about our next speaker, which is Dr. Lee and Seng. Dr. Lee and Seng received his bachelor degree in communication engineering honors degree and PhD in communications engineering from School of Computer and Communications Engineering at University Malaysia Perlis in 2012 and 2016. His primary field of study is microwave engineering. He's currently a senior lecturer at He is currently a senior lecturer at UNIMAP, fellow researchers at Advanced Communications Engineering Center of Excellence, and advisor of IEM UNIMAP student sections. He is also a professional technologist, senior member of IEEE, member of IET, MBOT, IM, and BEM. From 2012 until 2020, he had authored and co-authored 89 journals, book chapters, and conference paper. His current H index is 10 from Scopus. His dynamic personality and participations have earned him awards nationally and internationally in categories academic, research, and innovations awards. He had received 60 awards from national and international innovation exhibitions, including special award from Turkish Inventors and Innovators Networks TIIN and World Inventions Intellectual Property Associations WIIPA. He was received several national and international funds, total worth US 185K. His research interests include dielectric materials characterizations, microwave absorbers, antenna design, RF tests and measurements, So without further ado, please welcome Dr. Lee Yanseng.
Okay, thanks, Dr. Sai. Thanks for the introduction. Okay, so hi everyone. So I'm Dr. Lee. So I will share my screen now. All right. So so again, hi everyone. So I'm Dr. Lee from UNIMED. So today I will present about the remote learning laboratory experience for RF and microwave courses. Okay. So first I will introduce about UNIMED Keysight RF and microwave lab. Okay, a bit briefing, and the measurement setup, how is the measurement setup looks like, and how is the DAQ multiplexer works, and the live demonstration, and the feedback from our student. Okay, so this is UNIMED Keysight RF and microwave lab. So it's official launched by President of Yi Hui Sing from Keysight and our former Vice Chancellor, Dr. Prof. Barisha, at 5th of September 2019. So UNIMED have participated the Keysight Industry Ready programs. Okay, so total now they have like 16 students have received the RF and microwave industry ready student certification. Okay, not all the students will receive. We will choose the best. Is like they are good in RF and microwave. Yeah, and then so we will award them to receive this certification. Okay, so yeah, currently these two students is working at Keysight and Intel. This is our batch is like 2019. Okay, so and the list, right? The student have like selected, then their name will publish in the Keysight website. Okay, so next, so this is our lab for RF lab. Okay, so you can see from here they have like total is like 5 stations. Okay, so 1, 2, 3, 4, 5. Okay, so each station they have like 1 PC and a network analyzer, signal generator, spectrum analyzer, oscilloscope, waveform generator, and a DC power. So you can see all the bench is in here. Okay, so yeah, this is one of our training kits for RF and microwave courses. Okay, from Lecture. Okay, so you in face-to-face situation, physical, our student will experience to do the connection and to test each of the DUT device under test of, let's say, the low noise amplifier, the mixer, the power, the bandpass filter, and the amplifier. Okay, so student will like which DUT that they want to test, then they will connect the cables to the DUT and then do the measurement. Okay, for characterize the DUT. Okay, so this setup is roughly like the VNA connect to the training kits, and the training kits is connected to the PC. So Dreamcatcher have the software to like control the microcontroller here to turn on and turn off the, let's say, the active component, the amplifier, the low noise amplifier, mixer, and the amplifier, IF amplifier, and even the frequency synthesizer for the LO input. Okay, so next. Okay, why we, this is roughly the Keysight remote lab solutions. Okay, so they basically have like user can access to the remote remote lab. That means they can access to the cloud and to the PC in the lab. Okay, and then the PC is connected to all the instrument in the station. We call it station. So each station, the PC will connect to all the instruments and can measure each of the DUT. So this is not the DUT. This one is the multiplexer. This one I will talk about more detail later. How is the setup? Okay. So the DUT, let's say the instrument is connected to the DUT, then they can do the test. Okay. So okay, next I will talk about why we need this multiplexer. Okay. So let's go back to the slide here. In traditional way, when the let's say the COVID pandemic period, right? So our student is not able to attend to the lab. Okay, although we have the bench view software, but we need someone in the lab to change the cables for the student to measure each of the DUT. Okay, then the someone will be the lecturer. That means it's me. Okay, so we have 5 stations. That means I need to stand by at the lab for the 5 station. That means when students they want to check for the amplifier, I need to help them to change the cables to the amplifier part, and then they can do the test. Okay, so this is like previously what we do. Okay, that's why we need the multiplexer to connect all the DUT and then do the switching only. So the lecturer no need to present in the lab and no need to change the cable one by one. Okay, so about the multiplexer. Okay, so this is the DAQ. Okay, so let's say this is our PC for each station and connect to the instruments. Okay, and the multiplexer is connected to the DUT. So you can see all the RF cables, SMA cable is connected to the DUT. Okay, and ready to do the switching to activate which DUT that we want to test. Okay, so I will talk about more later for how this set up. Okay, so let's talk about the Keysight remote solution. So the Keysight solution, right, they're able to remote the desktop control. They can configure the instrument, yes, and they can do the measurement. Okay, so remotely access the lab bench PC. Yes, they can remote the lab PC, and they also can view the available instrument list connected to the bench. So you can see when the bench is connected to the PC, right? If available, then they will display in here. Okay. Next is I monitor the instrument status and configuration, so they can see like how is the status connected, or they can do the configuration here. Okay. So another tools from the Keysight solutions, like they actually have like they can have the chat box for better participant. That means students can chat with each other in the group. Okay, and file transfer after they finish their measurement, they grab their result and they file transfer to their group or to their PC. Okay, and scheduling and manage the remote lab session. That means they also can do the scheduling and manage the remote lab. That means they can book for each section that they want, and then they can access anytime. Okay, for this part, right, Unimed is currently in the process to integrate this one to our LMS. So I wouldn't demo for this. Okay, then okay, so the next one will be how the DAQ multiplexer works. Okay, so let's talk about. So this is the DAQ 970. The DAQ is not the multiplexer. So this is the front panel, and here will be the rear panel. So you can see the circles here, right, actually is to put in the multiplexer. That means they have each of this bench, they have like 3 slots. Okay, so each of the DAQ we can put 3 multiplexer, 3 different type or the same type multiplexer, depend. They have like for those like jumper cables one or the RF cables. Okay, and here we have like connection for LAN cable and USB. So it depends you want to connect your instrument using LAN or USB. Okay, so this roughly how it looks like. So at the first time, I also confused like with the multiplexer because they have called like DAQ and DAQM. Okay, I thought it's the same thing or a different thing. So but actually it's like a separate thing. That means this one is the DAQ, the data acquisition, and this one is the multiplexer. So multiplexer is like they have few types. That means like some is like for wiring, for jumper, for those electronic basic training kits. They can do the connection for the switching. And this one is fully for RF. That's why the model is 905 is for RF cables. Okay, so this multiplexer, right, we will plug in behind here, just now the 3 slot here. We'll plug in to the slot and put the cables will be out here, and then we can connect to any DUT that we want to test. Okay, so next one will be the DAQ. We will talk about like some information about the multiplexer. So this is the multiplexer looks like, and they actually can support like 2 gigahertz bandwidth. Okay, and their connector actually is like SMB. So you can see SMB is like a pin cables connector, and then you can just like pull out and pull in, and they will convert to SMA or BNC. So depend you want to connect to like your oscilloscope or your 6SA patternalizer or your VNA. Okay, so it depends. You can convert this. And the RF multiplexer is actually 2 independent 1x4 multiplexer. So what does this mean? It's like dual 4 channel, right? That means they have dual channel here. Okay, the dual 4 channel. So something like this. Okay, so they have like switches. That means you can, the COM actually is the source. Okay, so that means let's say I have a VNA, I can connect the port 1 to COM 1, and they will have the switches to channel 1, 2, 3, 4, which one I'm going to activate. And the port 2 can connect to COM 2 here, this side. Then we can do the connection for like, we can do the activation like channel 1, 2, or 3, and 4. That's why they are independent. Okay, so each multiplexer, they have like dua 4 channel. Okay, so what's the measurement setup in our lab? Okay, so let's say our measurement setup is like, let's say we have a VNA, nebulizer, a multiplexer, and the training kits. Okay, so first we will connect our port 1 for channel 1, 2, 3, 4. So this one will connect to the port 1 here for the VNA. And each of the channel, right, for port 1 will go for the input. That means the input for the mixer, bandpass filter 2, amplifier, and bandpass filter 1. So this is roughly how it looks like. Port 1 go to the COM, and they can do the switches between these 4 input. Okay, so how about the port 2? Okay, so it's the same concept. You will connect it to each of the output. Okay, so let's say we connect the COM 2. So you can see the channel 1, 2, 3, 4 is connected to the port 2. Channel 1 is connected to output here. Channel 2, channel 3, channel 4. Okay, so this is basically how is the connection. Okay, that means we need to connect the cables first, and we will define this in the benchview software. Okay, so let's say we're going to measure the bandpass filter 1. That means this one, this guy here. So this DUT here will be channel 1 for port 1 and port 2. So we're going to activate the switch to, let's say, COM 1, the port 1, will activate the toggle the switch to channel 1. And we will toggle the switch for port 2 to channel 1 for port 2. So we have activate here, and the data will automatically read from the bandpass filter 1. So how about we're going to go for power amplifier? So let's say this is the power amplifier we're going to measure. So it's like channel 2 for port 1 and port 2. So we can see we can toggle the switch from the switch 1, from the channel 1 to channel 2, and port 2 for the channel 2 as well. Okay, we're just toggling the switch actually. Okay, so next, let's say we're going to measure the bandpass filter 2. We just change the switch to channel 3. Okay, we just toggle the switch. So you can see the switch actually going down here now. It's connected to channel 3. So if they want to go for channel 1 and 2, they will go up here. Okay, so same goes to port 2. Next, for the mixer. So it's the same concept. See, it's like just toggle the switch to channel 4 and channel 4 for port 1 and port 2. Okay, so this, after we understand the concept, then we will go for the demo. Okay, so the demonstration, we will measure the bandpass filter 1, power amplifier, bandpass filter 2, and the mixer. Okay, so wait for me for a while. I will connect to our lab PC. Okay, so let me stop my screen for a while. Okay. Okay, now, okay, so, oops. I will share my screen now for the remote to the lab. Okay, hopefully you can see my screen. Okay, so this is the screen from the in our lab. Okay, our RF lab. Okay, so usually we have the guideline for students. They know what to do. So first step, of course, they need to turn on the bench view, Keysight bench view. Okay, so this one is like the Keysight bench view, and you can see the DUT, the instrument is connected, is ready here. Okay, something like this, and the spectrum and the VNA. Okay, so let's say the student going to do the RF, the training kits, right? So Dreamcatcher also have the software. So this software is to control, to activate those active component. Okay. Okay, but how the student going to view the real case in the lab? So we also have a webcam there. So student can turn on the webcam and see on the real situation in the lab now. Okay, so this is the connection like what I presented just now. So you can see its connection or is connect to the VNA and the DAQ is here. Okay, so first we're going to measure the band pass filter one. Okay, so we're going to see the check the neuralizer. So we will run it. Okay, so you can see the result is actually almost similar as, not similar, exactly the same from the VNA. Okay, so let's start our measurement. Okay, so let me turn on the switch here. Okay, this is the DAQ. We actually can change the name. Okay, so let me briefly like introduce how this thing works. It's something like, you can see the one, right? All is one at the first here. Okay, because it is slot number one. Okay, then the number one, the second one will be one here. That means it's like COM one, channel 1, 2, 3, 4, channel COM 2, channel 1, 2, 3, 4. Okay, so I will define this one, let's say input. Okay, because our channel for channel 1, port 1, channel 1 is input. So you can rename as you like. Okay, then we can actually like, if open, that means it's not connected. That means we need to put it like close and close for band pass filter 1. That means input and the output, the port 2. Okay, so let's see how it works now. Is it connected? Yeah, so you can see they have some response here. And also, we also can add on the trace here using the bench view. We can put like 2 trace. And now you can see they have 2 trace here. Okay, then we can go for trace 2 and modify to S21. So like band pass filter, right, we're going to see the 2 trace like S11 and S21. Okay, but you can see the result is like roughly the signal here is not that good, right, because of the calibration. So don't worry about the calibration. So actually, Keysight instrument that can connect to some of the software that can go to the interface. We can connect to our instrument there. Okay, so this is the instrument. Okay, so it's a different thing. It's not the, okay, so you can see now the screen is here. So actually we can go for here. Let's say previously we have done the calibration to all those cables, right? So we actually doesn't remove the cables. So we can actually go and recall back all the stack. Okay, so we recall back the stack for, let's say I have done previously. Okay, so you can see a bit nicely compared with just now. So let me try again. Let's say I can go back and preset. Yeah, sometimes students, let's say they have messed something wrong, they can just go preset, and then they can go back to the calibration, recall, and call back the channel. Okay, so record the state. There must be remember which state they are. Okay, so yeah. Okay, now we can continue our measurement. So we can close this. Okay, then we can go for the bench view again. So we can grab the data again. Okay, yeah, looks nice. Okay, so this is like roughly like how is the band pass filter for here. Okay, then let's say we're going to go for the second one, the power amplifier. Okay, so power amplifier will be channel 2 and 2 for port 1 and port 2. So let's go to the port here. Okay, so hold on. Okay, so we're going to go for like channel 2 here. Okay, so sometimes, yeah, this one is the view actually is like visualization is not that good if like it's like a bit boring, right? So you actually can go for graphic setup. Graphic setup is interesting. It's like, for me, it's interesting because you can see they can do actually like the switch. So student very easy to understand where is the switch they have turned on. So we can name it like here, input for power amplifier, band pass filter, mixer. Okay, I make it bigger. Okay, and then for output, port 2, band pass filter 1, power amplifier 2, and band pass filter 2, and the mixer. Okay, so now we have this. So now I'm going to turn on the amplifier, right? So let's say I have accidentally turned on only the port 2, the output, but the input still there, still in bandpass filter 1. So we can view from the analyzer. You can see they have the bandpass filter for S1 is okay, just the S21 is not connected. Okay, so let's go to power amplifier. So we turn on the power amplifier and the output is power amplifier. So now let's run. Okay, so roughly now you can see the amplifier is here. Okay, so for amplifier, right, of course, we're going to test the isolation and the gain. Okay, so with the training kits, right, limb catcher training kits, we can connect to the transceiver. Okay, because our instrument here is a transceiver kits. Okay, then we're going to activate it. Okay, so once we choose the transmitter and we connect to the training kits, okay, now it's connected. And you can see from here, right, here is the bandpass filter. This one is the power amplifier. So you can see the light is on and off here. Okay, before this, we need to careful with our power. So yeah, so usually for checking light amplifier, we will go for low power. Okay, so it's like we also can change for the power, negative to negative 4 dB is fine. Then we're going to turn on and turn off. So I will show you how it looks like. So let's say I turn on, right? So you can see the LED is here. So let's say I turn off, you can see it's blinking. Okay, and also you can view the graph is changing. Okay, yeah, so this like can let the student confidence their connection is okay, everything is connected. Okay, then now we are open, then the LED is on. Okay, so we will go for the bench view here, we will view the result. So let's say we view this result, we can just run it. Okay, so you can see the results here. Okay, and the marker. So usually we will use the marker to check the result, right? So we can go for like maximum. Okay, but you can see it's like doesn't change, right? So sometimes like because of the tracking, but don't worry, we can just go here and then go back to the S21 because now it's like in blue color S21. We will go for maximum tracking. Voila. So you can see they are going for maximum, but the result here they show is the trace 1. How are we going to go to trace 2? We can just view from here. We can just change it again and again. Okay, so you can see 500 megahertz with 16.81 dB. Okay, maybe this one is too small for us. We can go for the screen image here, get the current screen. That means everything that show in the screen now in the VNA. Okay, so we have the current screen now. Okay, this is a good function for the student. And also they can change the marker not only to trace like maximum or minimum. So we can see like remove. And we can do like x68. Let's say we want to check x68 megahertz. It doesn't remove because they have the trace 1 here is tracking the maximum. Okay, so we need to remove this. Okay, now let's try for here. And now you can see we are moving to S68. Yeah, S6 and what's the gain? Okay, so this is the demonstration for amplifier. So after we off it, then we can get the result. Yeah, it's different. So the student have to very good in fundamental to like hypothesis, like what's the result, and then they can understand if they feel like something weird with the result, right? So maybe it's a connection problem or anything else, right? So they must really know their result. Okay, so this is good to build out the student fundamental theory part about the result. Okay, each device. Okay, so next we will go for bandpass filter 2. Okay, so the connection will be like channel 3. So it's the same process. So here we will go for AQ and we will toggle the switch to bandpass filter input and the output. Okay, so next you will run it. Okay, you can see it's like it's very narrow and at the lower frequency. Okay, so it's okay. So we can also view in the camera. Yeah, it's correct. Then we can change the start and stop frequency. So don't worry, we can just change for let's say 1 gigahertz. Okay, and here how about 800? It looks good. Okay, how about 900 for the stop? Okay, but automatically go to 3 gigahertz. Why? Because we doesn't change the megahertz here. Okay, so ta-da. Okay, for this. We also can add on the markers to check the bandwidth. Something like this, we can add on the marker. We have like marker 2. We can turn on. So now you have like marker 2, and then we can put it at, let's say, 800, let's say 850. Okay, somewhere here. Okay, so you can put like 865. Okay, somewhere here. So you can put like, actually you can have like few trays. You can have like 3 trays. You can turn on and go for another bandwidth. Okay, so this is roughly what we can do from the bench view. Okay, it's like actually what we need. Okay, next we will go for mixer. So mixer is the same. We can just go to the mixer part. Okay, it's the same. We just go to the DAQ. Hold on. Okay, DAQ and mixer. Turn on the mixer and run it. Okay, so we actually also can see like, let's say now the mixer is maybe it's not 800 to 900, right? So maybe you can wait if like full 500 to 3 gigahertz. So change to 3 gigahertz. Okay, so we also can view in, let's say we have a DQ here, right? We can view in the camera here. Okay, so is it affected? Let's say I change. Okay, yeah. So you can see the S21 is changing. Okay, so it's good. Okay, so we also, the mixer also, they have like up converter. That means it's an active component here. So you can view from the, here you can see it's like we can turn on and turn off as well. So this one is like fully remote for the student. Okay, so I think I have present all how is the remote works. Okay, the last one. Okay, the last one. The training kits, right? Actually, they also have the frequency sensitizer for the LO. So I can demo this as well. So you can see from here, right? The LO, okay, here. The LO part here actually is like, not LO, frequency sensitizer. We can check the output from the frequency sensitizer. If you buy a frequency sensitizer, of course, you need to check what is the output. So we connect to the spectrum. And here is the control to turn on the frequency sensitizer. So you can see the peak. Okay, when you want to turn off, then they will have like a warning, turn off the sensitizer, click on shutdown. So we need to click on shutdown. Oops, okay. Click on shutdown and then connect again. Okay, so let's say you can see they have no peak because we are turned off the frequency sensitizer. Now let's say we turn on, we have the peak and all this is harmonic. Okay, how are we going to check this? We can go back to our bench view and go to our spectrum. Okay, we also can support spectrum. Then we can run it. Okay, so you can see they have like 3 peaks. Okay, from here you also can add the add on the marker. Okay, to check of each peak. So let's say I run it, how it looks like. It should have the marker here. Okay, hold on. I think I have turned on. So let's see. Okay, so you can see the marker here. So let's say I want to change the marker to 850 megahertz. So I run it. Then is it go to here, 850? Yeah, somewhere here. So you can see 850. Then I can ask them to peak search. That means they will check the maximum peak automatic. Okay. Yeah, you can see here. And then if they want to go for next peak, they will go for like next peak in the right or the left. So right hand side, I just click on it. You can see it's automatic go for 1.637. That means here. Oops. Yeah, sometimes you need to refresh few times, then they will go for here. Okay, so 1.637. This one is the harmonic from the 818. Okay, sometimes the student will ask, it's like, it's not exactly 818 the maximum because 815. Don't worry because of the bandwidth. So you can just put like 818. They are still there. Okay, so you can see it's 818. Oh yeah, maybe it's too small for you guys. So we go for the screen and we get a current screen for the spectrum analyzer. Okay, the good thing is from here, right, the screen, we can share the result and the report as well. So let's say my student, they want to like highlight this one is the result. Okay, and they want to point out their result for the marker. Okay, so they can do something like this. Okay, and they also can do like maybe something else I want. Okay, or change the color font. Yes, they can do that. Okay, and also they can do like the point is like something like this. Okay, then they want to send this as a report. They can just go to export. They can send as a Microsoft Word or a image. Okay, let's say we go for Microsoft Word. Let's say we go for image first. Okay, we just save as in the desktop, and you can choose like the date, time, and numbers. Okay, and the good thing is the student, when they have doing this image right in their report, right, it's the real time from the PC. That means, yeah, it's their lab section, and they're doing is not copy from previous, maybe the senior or the previous student. Okay, so they also can browse this and change the name, but they can't change the image. Okay, so let's say example, we can copy this, we can export this. So now we have the result here. You can view it. Okay, so this is the result. Okay, it's quite nice. Then they can just copy paste in their report. Okay, sometimes you also can export to Microsoft, but you need to wait for a while because they're going to generate the report automatic. So hold on. Yeah, in the process, so just wait for a while and they will pop out with the Microsoft. Okay, so when they're done, so this is the result from the student. So even the serial number, which lab they are using, okay, the period, which model, the serial number, and the visa, the address. And this is a screenshot. Okay, so this one is like very easy for students to do their reporting as well after they measure their DUT. Okay, so another good thing is, let's say we have the VNA here. Okay, then we can go for the trace. Some researchers, let's say they want to have the data for the whole row, the whole frequency in table form. Yes, we can do that. We just get the trace. Okay, we can choose. Yeah, I think we can get the trace. We can, oh yeah, we can choose the channel 1 and channel 2 first, get the trace. Okay, now they have here. Then we can just export. Okay, here is like, we can choose like channel 1, channel 2. Okay, so we can just export to CSV, Microsoft Excel, to the ADS or MATLAB. So let's say we go for Microsoft Excel. Okay, let's see how it looks like. It's good for those researchers to collect the data directly from the VNA. Okay, so something like this. So you can see the frequency, the trace, the S11, the real part, imagining part. Yeah. Okay. So this is how this instrument, this benchtool works. And if you want to find more, let's say you have others instruments, you can go to the home, and they have a lot of application. Okay. Then you can just search the model that you want. Let's say DAQ, let's say the DAQ, and then you can install, or you want to find others thing like, okay, scope, yes, you can update or purchase it. Okay, so this is how roughly benchtool looks like. And wait, next will be, yeah. Okay, I think I've done for the demo. Okay, so we're done for the demo. So let me share back my screen for the presentation. If you have any question, you can just put into the chat box, then I will answer it. If you're any confused about the remote. Okay, so hold on, I will share my screen now. Okay, now we have demo the bandpass filter, and power amplifier, bandpass filter 2, and the mixer. Okay, and also the frequency synthesizer. Okay, so it's like fully remote. Okay, this one is like other thing that you can do. You can check about what is the maximum gain and the frequency for the amplifier. The gain reduced to 3 dB, you can move the marker. And how about the isolation of the PA? Oh yeah, you can change the trace to S21. Okay, S12 or S21. Then you can know the isolation. And you also can put like input return loss. Yeah. Okay. Next, this is the sample that I get from the datasheet from Keysight website. Okay. So in the datasheet, they have mentioned like they can configure this whole transceiver training kits from the Dreamcatcher. Okay, how it looks like. This one is like the normal connection. Okay, it's not the multiplexer one. So they will connect like the frequency, and then they will put into the up converter, filter, and amplify it, and go to the band pass filter and transmit and to the receiver. Okay, so for full connection, yeah, in the datasheet as well, they have like connection how to use the multiplexer, okay, to do the connection. And if you face any difficulty of the connection, right, yeah, you actually always can refer to Keysight or Techmark. Okay, Techmark is their sole distributor in Malaysia for of Keysight. So they will always send their support to help us out. So don't worry about that. So okay. So the summary. Okay, this remote lab, right, is provide a convenient way for online learning, and student is work with industry grade test and measurement instrument and software, like Mr. Daniel said. Okay, the instrument is used in the industry as well, and the software. And student gain the application knowledge as industry engineer. Yeah, when they're in the lab, they do the remote, the connection, and then yeah, they already have the knowledge for like industry engineer. And then the benefit now is student also able to learn how to remote and control the instruments using software. Okay, not like maybe my time is like we do all manually direct to the VNA. We doesn't use PC to control the instrument. Okay. Okay, so this is the benefit. Although let's say maybe after the pandemic, we will have like face-to-face section. We also will teach the student how to set up the remote learning, the remote lab. Okay, because now they are currently is like remote how to use, but after that we will teach them like how to set up, what to install, the visa, the connection, how to connect, communicate between the instruments, and what is the thing that we need to prepare for remote. Okay, so this is one of the advantage now. Okay, so okay, this will be the last section, the feedback from our student now currently working at Micron and UST. Okay, so yeah, let's hear about what our student feedback. Okay, if you can't hear me, please let me know.
Hi, my name is Hasnul Haikal bin Hasnul Azhari. I'm an Electronics Engineering Technology, Electronics Telecommunication Design graduate from University of Malaysia, Belize. Currently working as a validation engineer with UST Global. Today, I would like to take a little bit of time to talk about the usability of Keysight BenchView software and how it has helped me and my classmates to do our laboratory works during the pandemic. Keysight BenchView is essentially a software that allows you to connect or interface with Keysight instruments that are placed in our laboratories in UNIMAP. This allows us to do our laboratory work from the comfort of our home without needing to go to the laboratory itself. Without the presence of Keysight BenchView, we will not be able to do our laboratory works during the pandemic. And the fact that our respective lecturer, Dr. Lee Yang Seng, is very knowledgeable in BenchView and has to teach us how to use it, how to perform the experiments, how to extract the data from the instruments, whether in Excel form, picture form, it allows us to do our experiments easier because we can extract the data, we can tabulate the data directly from the comfort of our home. I do think it is not an exaggeration to say that without Keysight BenchView, we wouldn't be able to do any of our laboratory works during the pandemic. So the combination of Keysight BenchView and Keysight instruments that are available in our university has definitely allowed us to do the laboratory works and thus prepare us better for the working environment that we are facing right now. And since we're able to do the experiments from home via Keysight BenchView, we are able to achieve our CLO or cross-learning outcome. So by far, me and my friends are very satisfied with Keysight BenchView, and I hope this system can be implemented in the near future, even without during the pandemic. For some, maybe if we have natural disasters or we have no access to the laboratory work for unknown reasons, Keysight BenchView is there to help. So this is a very good tool and a very good software that interfaces us with the instruments that we need to perform our laboratory works. So to end this short video, I would like to acknowledge and express my gratitude to Keysight for developing BenchView. This tool is very helpful and allows us to do our laboratory works during the pandemic. Thank you to UNIMAP for implementing this system into our laboratory works. Thank God we are able to do our laboratory works because as an engineering technologist, laboratory is in our blood. We cannot function without laboratory works. And then Special thanks to my lecturer, Dr. Lee Yang Seng, for his guidance and know-how. Thank you.
Hello, I'm Aina from UNIMAP under Telecommunication Design Engineering Technology. Currently, I'm working as a quality engineer at Micron Technology Malaysia. From my experience doing lab during this pandemic, Keysight BenchView has made it easier for us to remote lab easily from our home. It allows us to configure instruments smoothly. Furthermore, the most crucial thing about this Keysight BenchView is we can easily export the data that we have collected from our experiment for our lab report requirement. How I learned to use BenchView is that with my lecture guidance, I get to use BenchView easily. It itself was not so complicated and direct.
Hi, my name is Young Ik Chun and I'm from UNIMAP under program Telecommunication Design Engineering Technology. Currently, I'm working in Micron company as a QMS engineer. From my experience of learning remote learning lab during this pandemic, Keysight BenchView has helped us through by remote learning in the lab. BenchView is very easy to use and easy to configure the instrument, and most importantly, it is also helps to export data in JPEG, Microsoft document, and also Excel for our lab report. It's really helped us to ease down with doing this RF lab report by using this remotely, and it also helped to achieve the cost outcome. And I'm very satisfied in using this Keysight BenchView. Although we don't have the chance to even touch it physically or even enter the lab itself because during this pandemic, but I'm glad and I'm very satisfied that at least we can try to learn the Keysight BenchView through the remote. Also, I have learned something remotely rather than nothing. All this while I've learned in this RF subject is in my university and through my guidance, which is my lecturer, Dr. Lee. Moreover, he also do provide us link how to use it, and also with an additional PDF file for us to learn and also get the exposure on how to use this lab Keysight BenchView remotely. And I would like to thank my sir, friend, as we could do this all together. And it was not really easy in these pandemic situations, but I do learn and also experience it remotely. So thank you.
Okay, so that's all from the student. Okay, so yeah, I will end my section. Thank you for your time, and yeah, we are welcome for the Q&A section.
That is actually a very nice testimonial coming from the student. You know, what is really interesting was the student, you know, they said that they are still given a chance to continue to learn and also to work together with their course mate, even remotely. You know, I think this is one of the, as an educator, I think the lifelong learning kind of like objective is met.
Yes. Yeah, and yeah, I think, yeah, and then I also want to tell like everyone here is like, if you're interested to pay a visit to UNIMAP or experience our remote lab, right, remote RF lab, just please contact me and we will do the arrangement. Okay, so thanks. Yeah, so now it's like Q&A section.
Right, thank you, Dr. Lee. Is there any question from members of the floor? I saw in the chat area there is a Q&A session that happens between between Daniel and the rest of the participants. So, is there any question for Dr. Lee and Seng? And if you have any questions or you're interested to visit to UNIMAP, you also can contact Dr. Lee at yslee@unimap.edu.my. Any questions? Let me see in the chat area. Seems no question. Any question from the participants?
I think I saw some after. Wait, hold on. Oh, yeah, I think Daniel have answered.
Yeah, perhaps I answer everyone.
Yeah.
In fact, Aiman, I will get in touch with you. Yes, we definitely have this. We can catch up with a demo for you, a live demo too, on the integration of the LMS. I would say for all the educators in Malaysia and also in overseas, if you have the opportunity to do improvement in your current teaching lab to enable students to get a better job or to modernize your lab, even to support young researchers doing their research work remotely, we are here to assist you. Don't wait because I think Keysight, we are more than happy to assist you. In fact, if you are looking into some sort of applying your local government grants application and you need some sort of like industry support, like such as Keysight, we are here to assist you to strengthen your grant application as well.
All right, it seems like Yusuf Idris has raised up his hand. So, Mr. Idris, you may ask a question. Is it? Or maybe he just mistaken. Oh, okay, we have a question from Natra Zamani. Hi, may I know if there is any other applications that can be used other than Benchful?
Yeah, the bench. So I think Daniel.
Okay, I can take this. The answer is yes. Okay, definitely yes. But again, the one that we know today is that can offer so much capabilities, and then also at 50 users at the same time, 50 students log into the lab at the same time. There's none. Only Keysight can do this at this moment. There are definitely other ways, but you may bump into user license agreement, like this is only for 1 or 2 user. You may not use in any organization, so you do not want to run into any legal issues on the licensing part. That I highly recommend not to do that. In fact, if you do that, it may affect your university reputation and ranking. Right. Yeah. Now you can use remote desktop, this and that, but that doesn't actually, you can work well in a small group, but in terms of Benchful actually is a tool that connects all your data. You can multiple instruments, single connection. The keyword here is multiple connection, multiple measurement, single connection, allow you to access it. And yes, I'm not promoting Keysight. Well, of course, I definitely part of Keysight, but even the industries are using this. So short answer, yes, there are other tools to do that, but to go to the capacity for engineering, purely engineering measurement, there's none.
Okay, so I think I saw the chat box. Li Hong, Lian Hong is like commenting. Yeah, Lian Hong is from the Dreamcatcher. So yeah, if you need the Dreamcatcher training kit, yeah, you can refer to him.
Yeah, maybe Lian Hong, you can drop your email address here as well.
Yeah.
Now, I would like to comment about Dreamcatcher. So Dreamcatcher actually provide a great selection of engineering training kits. Their courseware are being used worldwide as well. I saw that in Korea, in Japan, in Australia, even in US a lot. So it is a very simple to follow, comes with lab, training slides, kits are robust, qualities are good. So yeah, it works well with Keysight instrument very well too.
Yes.
Okay, so Mr. Samson, perhaps he would like to ask a question. Please, Mr. Samson. Okay.
Yeah, maybe forget to unmute.
Good morning.
Oh, yeah.
Yeah, morning.
Good evening. I don't know, maybe morning, evening.
I want to ask a question. I'm speaking from Nigeria. Currently, we're working on MIMO technology. So I asked once before now, but I want to clarify again. Using this remote lab, can one perform any measurements on MIMO technology?
Okay, Samson, the answer is yes, but you definitely need to know what are the instruments you are going to use. Second thing is, what is your connection type to your DAT? How are you going to connect it? So if you have someone located in other countries where your DAT, your measurement is connected remotely, it's important to look into what are the instrument you have, what's the connection to your DAT, and of course, I have to say that a lot of industry-grade instruments today, they provide remote access. These are nothing new, but it has been used in the industry many years already. What we are doing today is just offering up the same to educators, researchers, at a lower cost, and also tuned to the UNICE program. So industry-grade instrument, if you're using one like maybe a signal analyzer, a test bed, you just need to connect remotely. You can do that. A lot of this software, like maybe like Keysight VSA tools, allows you to remotely connect as well.
Okay, thank you so much.
Yeah. Most importantly is to know your DAT and the instrument and connection. Yeah.
I think we have from Vincent. He asked that, hi, Dr. Lee and and Mr. Daniel Yap, are you looking for collaboration?
Yes, of course. Very welcome. Yeah. So yeah, anything you can just drop me an email, then we will have further discussion. Yeah.
Yeah. I mean, coming from the industry, from Keysight, Keysight is open for any collaboration ideas. However, we are very selective in the collaboration topics. One thing that Keysight is looking at, a lot of this collaboration are focusing in emerging technologies. As you've seen earlier on, like 6G, quantum, green energy, stuff like that, security. So if you are working on something on this area, yeah, let's talk. We're definitely interested to understand more about your work.
Okay.
Right.
Yeah, I'm going to add on something about the MIMO part just now. So the MIMO part, right, is actually the bench view definitely can support because they just connected to the instruments. But for the multiplexer here, we need to concern about the bandwidth. It's only 2 gigahertz. So if your MIMO is higher than this frequency range, then yeah, it's not able to support. Yeah, this is for your information.
Unless of course, Dr. Lee, that's right. Unless you have a direct connection without the DAQ, it's possible. Yes. So that's why look into your frequency range, what you really need. Short answer yes, is yes, but we still have to relook what are you measuring at.
Yeah.
From Mr. Lee Hong Lim, if you have any inquiry about training kits, do contact me at lhlim@dreamcatcher.asia. I think it's one of the from industry as well, right?
CEO from Dreamcatcher.
CEO from Dreamcatcher.
Yeah, our training kit from him.
Oh, okay, all right. Is there any more questions before we end our session today? It's already 11:30. Okay. If I may ask, can we get the record sessions and the slide presentations? Can both of our presenters share? Would you like to share your presentation today?
Yes. Yeah, no problem for that.
Yeah, okay. No problem for me too.
Yeah, I will share. Sure. Yes.
So don't forget to fill up the registration, the attendance forms. Then we will share the record sessions as well as the slide presentations.
Oh, there is one more question.
Yeah, there is one more question from Kabinage. For Dr. Lee, I guess.
Yeah.
Hi, as shown by Dr. Lee, there is a way to do setup for transmit and receiver stations for testing and measurement setup. Does it require 2 separate bench view or 2 separate PC, or can be done in one PC, I guess?
Okay, yeah. Okay. Hi, Kabinish. So, as I know from the Dreamcatcher one, yeah, at the same time, you only can activate like transceiver. It's the transmitter or the receiver at the same time. Okay, that means you need to have 2 PC to activate the receiver and another one to activate the transmitter. Okay, and the bench view, we no need to separate 2 bench view. Yeah, as long it's connected to the instrument. Let's say the instrument, the VNA is connected to the bench view. Then the input and the port 1 and port 2 is connected to the transmitter and the receiver, then we'll be fine. Okay. So, but for the Dreamcatcher one, yes, I think we need to have 2 PC to activate the software. Okay.
Yeah. So bear in mind too, in terms of bench view, it comes with 50 seat of bench licenses. So you only pay a small fee and you can open up to 50 users measuring at the same time.
Wow.
And maybe as a lab manager like Dr. Lee himself, he can view, monitor 50 users at the same time too. Yeah.
Yeah. At the same time, the student have performed their measurement, right? I can access to their PC and check their bench view result. Yeah. Or I could just go into the client, and I mean the student bench view, then I check on their result as well. Okay.
Well, good, very convenient.
Yes.
Perhaps we can take like one last question. Is there any more question before we end our sessions and we do a group photo?
Okay.
Is there any more question? Check. Let me check in the Facebook if we do have a questions there, because we also do a live streaming at the IEEE AP EMC web Facebook.
Oh, that's interesting. I didn't know that.
So we also live. Huh?
Yeah, we also live. Okay. Seems like no questions here. Oh. All right. Okay, there's no questions on the Facebook. I think that's all. It seems like no more questions from the members of the floor. Can we take a group photo before we end our session? So I would like to seek cooperation for all the members, for all the participants to turn on your camera so that we can take a group photo sessions, and then I will share in the Facebook as well. Okay. Okay. All right, ready everyone? Smile. Okay, thank you everyone. Thank you for all your cooperations and thank you for willingness to be with us today. So hope to see you guys in our next webinar, which is webinar 12. And I would like to say thank you so much to Mr. Daniel and Dr. Lee and Sang for your willingness to share with us with all of these in our sessions, in our sharing sessions. So hope to see all of you again in our next webinar. Thank you so much and goodbye. And don't forget to share.
Thank you. Bye.
Thank you. Bye-bye.
Thank you.
Dr. Lee, Mr. Daniel for the sharing.
Thank you.
Yeah, welcome. Thank you.
Thank you.